Hi, in this lesson I want to go through the answers to the Trilobites study task. If you haven't yet completed the questions on the study task, this is the point to stop the video and have a go at those questions. See if you can work through the data that's been given about these amazing and enigmatic little creatures. If you have completed those questions, let's go. Let's have a look at what you've come up with. So the first question is really about interpreting the descriptive data here of the evolutionary history of the trilobites, looking at their changing diversity over time. Now, this isn't something you'd be expected to know, but you should be able to interpret the data fairly straightforwardly from this description. So if I draw the graph, we've got them appearing in the Cambrian, diversifying quickly, reaching their peak in the early Ordovician, declining then gradually during the Silurian and Devonian. By the Carboniferous, there's really a very small number, and they eventually disappear in the Permian. Okay, you get a point mark for their appearance, mark for the disappearance, mark for showing some other feature of the graph on the way. A fairly straightforward question, I think. Question 2 then, asking you to identify different groups of trilobites. Now, again, you are not expected to know these. There's no requirement at all to learn any species names at all for Geology A level. This is all about responding to the data and recognizing the description of these, and in particular the different parts of the trilobite, which you are expected to know. Anyway, if you look these up, Olenellus is specimen C, and Paradoxides is trilobite D. You're then asked to suggest some modes of life for trilobite A and trilobite B with the evidence that we've got. For trilobite A, it's a trilobite called Trinucleus and is a burrower, or a bottom dweller maybe. But we pretty much interpret this as a burrower. Now there's quite a bit of evidence for this. It's blind. So didn't need or must have lived in an environment without light, where eyes weren't an advantage. Notice just to explain these bits of evidence, not just state them. Okay, make sure you're answering the question carefully here. It's got this margin around the cephalon that was possibly used as a shovel. Also, the pores around that margin may have been used for filter feeding, may have been used for sensory purposes. That margin and the spines coming back off it may be used to support the weight of the animal in very soft mud. Any two of those will get you the marks. Key thing there is to make sure you've explained the evidence. You don't just state it. For trilobite B, its mode of life is fairly clearly a swimmer. Again, lots of evidence for this. Those enormous eyes. On each side of the cephalon, it can see pretty much all the way around it. Its peripheral vision must have been enormous. It has quite a streamlined shape. The glabella, the middle of the cephalon there, is quite large, which may well have given it some buoyancy. It was also quite flexible, lots of thoracic segments. There are extensions on those thoracic segments. And also, if you look around the pygidium there almost looks like a paddle on the back of that for swimming around. If we then look for some morphological differences between A and the other three trilobites, we could be looking for the fact that A is blind, B, C, and D all have eyes. This frill margin around the cephalon that A has that the others don't. The genal spines, all of them have these spines coming back off the cephalon. A's, though, are significantly longer than its body, unlike the rest of them. A has a small number of thoracic segments. You could actually count them. B, C, and D all have more. They're clearly more flexible. Okay, I'll put some numbers on it. All numbers are always a useful thing. We'll always get you credit. The fact that there's spines on the thoracic segments of each of the others, there aren't on A. So there's lots of things to actually go at there. We then have, to go back to the graph, the ediacaran fauna represent the oldest, most diverse set of multicellular, soft-bodied organisms, the possible link to the early appearance of trilobites. This perhaps goes back to the first life video that you watched. We don't find any evidence of trilobites before the Cambrian, because these mineralized skeletons, the ability to form hard shells, only occurred within the Cambrian. It's part of the Cambrian explosion. The fossil record is biased. If organisms have hard parts, they stand a far greater chance of being preserved than if they don't. So if we had soft bodies before that, preservation then is extremely unusual, extremely rare. So any sort of precursors of the trilobites wouldn't have preserved, or maybe only in exceptional circumstances. So you're then asked to mark when the ediacaran fauna flourished. Clearly, it must be before the evolution of the trilobites, or somewhere in the late Precambrian there. The exact time doesn't matter too much, it just needs to be in the late Precambrian. And then why was there this sudden development and diversification at this time? Could be new niches opening up, new environmental changes leading to new opportunities for this evolutionary development. So the environment changing, perhaps climate warmed to make it more favourable for life, different nutrients in the sea. Okay. Notice the command word in this question. Okay, we've got annotate, okay, to put on the graph, but it's suggest. Remember that a suggest command word tells you that the information isn't necessarily on the data. You need to be thinking, bring in your geological knowledge. For example, for an increase in chemical weathering was actually putting more and more calcium into the sea. So at this point in time, right at the start of the Cambrian, there was perhaps suddenly an excess of calcium dissolved in seawater, giving the raw material for these organisms to evolve the opportunity to grow shells. And maybe that there was increased carbon dioxide as well in the environment, because that's also needed to bond with the calcium to make carbonate shells. So, to conclude, that question is typical perhaps of the type of question you might be asked about these organisms. Employing the basic understanding we have of their form and function to interpret maybe types of fossils that you haven't seen before. But it's not about remembering every type of trilobite there is. That's not really possible at A level. It's about applying your understanding of these organisms to new situations to use the data that's been given to come up with sound conclusions, sound interpretations of that data. We need to think more about this idea of preservation, and in particular, preservation of things that don't normally preserve. The type of things that perhaps came before the trilobites. But that's for another lesson. I'll see you then.